Hello everybody, it's Miss Thompson here, and I'm going to talk through our start of our second part of this unit, which is about functions. So there are 3 videos that all pretty much go together. 1.2a is about what functions are, 1.2b is a reminder of some common functions you'll have seen before, and 1.2c gets into some of the characteristics and attributes of functions that we'll talk about a lot in class. So this video is an overview of just a couple things. So what is the definition of a function? How do we represent functions? And the vertical line test, which is how we actually test, is it a function? So is it a function? And that's one thing we'll use, again, a lot in this class. So to get this going quick, in order to define a function, it's useful for us to define a relation. And a relation is actually just any rule that matches inputs to outputs. So any rule that matches inputs to outputs. It could be a rule that is linear or quadratic, or even a simple rule like when I give you the letter E, you move it up 4 in the alphabet. So E, F, G, H, I. That could be a relation. Doesn't have to be numbers. It's just anything where we're taking 2 different sets of things and coming up with some kind of rule between them. So very, very flexible. We don't really care about relations in this class, but we define it because a function is a special kind of relation. And the difference between a function and a relation is a function has a specific rule, which is that it is a relation where each input has only one output. So each input has only one output. What that means is that in kind of like layman speak, that each x in our function, in our equation, only maps to one y. So it has only one y value. So if we have x is 2, you only have one answer, y must be 4. You don't have situations where you've got x is 2 and y is 7, and x is 2 and y is 9. That would not work for it to be called a function. So one way we tell this is we use something called the vertical line test. And the vertical line test actually just shows us whether or not each x has one y value or more. So these 4 are just a quick example of that. The vertical line test is easy to do. Essentially, you just draw vertical lines. I'm not kidding. It's pretty straightforward. You just draw vertical lines. And so on this one here, I'm going to start by just drawing some vertical lines across my function, just a couple in a couple different spots. And what the vertical line test is testing is that each of these pink lines is an x value. And I want to check how many times my pink line crosses my function. So it crosses here, and here, and here, and here. And you can see that for each x value, I've only got one place it crosses. So that means that this follows our rule. Each x has only one y. And so this counts as a function. This fits our definition. This one also, if I draw my vertical lines, I can see that we have across here, 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 and here, but no pink line crosses twice. So this is also a function. And lastly, I can do this one, and you can see already, this line crosses twice, this line crosses twice, this one also, oh my gosh. And so what this means is that when I plug in an x value here, I get 2 y values. So this is actually not a function. This doesn't follow our rules. And this one is also curved, but when I draw my lines, I still only get one intersection. So we'll call it a function. So that's the first thing, is that a function has to be each x has only one y, and we can test that on a graph with the vertical line test, sorry. The second place you might see functions is in tables. And when functions are in tables, we can still test for them. The question we're asking here, this is example 1, it says decide whether the tables represent y as functions of x. And what that question is really asking is, are there any inputs, which are x's, with more than one output, or y? So it seems like kind of a strange question, but really they're saying, are there any x's that give you more than one y? So to check, I'm going to start with this one over here. I'm going to go through my inputs. -1, 0, 1, 2, 3. All of those inputs are different. All different inputs. So there's no place where one of these inputs has two answers. So this is a function. This counts. But on this side, if I start looking here, I see that I have 3, 4, 5, 4, and 10. This input appears twice, and one of the outputs is 7, and one of the outputs is 14. So I've got one input, it's 4, with two outputs. So this is not a function. Not a function. So pretty easy test there. Just as a quick thing, video 1.4 is all about function notation, but just so you're a little bit familiar with it when you see it later, we write functions, we kind of drop the y equals mx plus b. We drop that y really, and we write a function as f of x equals mx plus b. This is a linear function, obviously, because it's mx plus b. And so this essentially replaces our y. And what this is you pronounce it as f of x, or a function of x. It's just notation. It's mathematicians making things specific. And it means that I've got a rule, a function, that has an input of x, and this is our output. So the rule might be a function of x equals 2x plus 5. And that means when I put in x, I get out 2x plus 5, or mx plus b.